is Joyce. I'm the head of science department at WUIS and also IB chemistry teacher. Inquiry has always been at the core for both science education and IB philosophy. Rather than simply delivering the knowledge, we aim to cultivate curiosity, critical thinking, and genuine understanding of how scientific knowledge are constructed through modern technology and hands-on experiment. Today, I would like to share one example from our IB chemistry classroom. When students study transition elements, one of the first things they notice is that many of these compounds are colored. Instead of just telling students that copper sulfate appears blue because it absorbs certain wavelengths of light, we invite them to investigate this question themselves. Using vernier spectrometers, students measure the absorbance spectrum of the compound, analyzes maximum absorbance at different wavelengths, and then use real data to draw evidence-based conclusions. As an IB school, we are committed to providing students with access to advanced scientific equipment, with many different types of vernier sensors available in our lab. Our students are empowered to design, test, and refine their own experiment, fully supporting inquiry-based learning in science.
Ever wonder what chemistry really looks like? At WUIS, we bring A-level chemistry to real life. Go beyond theory with at least 2 hours of dedicated hands-on lab time each week, mastering techniques, conducting real experiments, and seeing science in action. But that's not all. Our small classes mean personalized individual tutoring support for every student. Get your questions answered, tackle challenging concepts, and build confidence with experts by your side.
A-level physics at school combines strong theoretical teaching with regular practical work in the lab. Theory lessons help students to understand physical laws and equations, while practical experiments in mechanics, electricity, and waves allow students to see these ideas in motion. Practical work improves skills such as accurate measurement, data analysis, problem solving, and safe use of equipment. By linking theory with experiment, students develop deeper understanding and confidence in physics. This balanced approach prepares students well for examination and future careers in science and technology.
At WUIS, inquiry-based learning is a very important approach in science curriculum. Through experimental investigation, students develop research questions, design procedure, and use the scientific equipment to test their hypotheses. Today, we meet 2 grade A students, Eva and Cherry, who choose public health as their investigation focus. They will conduct an experiment to evaluate the effectiveness of a formulated disinfectant.
In our investigation, we designed and prepared a disinfectant using alcohol, essential oils, and purified water. Our inquiry focuses on how the concentration of alcohol influences the effectiveness of the formulation. During the process, we carefully measured materials, controlled variables, and followed lab safety rules to ensure reliable results.
Today, we are carrying out a preliminary experiment to test our formulation under controlled conditions. Sample petri dishes were prepared and handled using an ultra-clean workbench to prevent contamination. The samples were then placed in an incubator to maintain stable conditions during incubation. These scientific instruments allow us to control variables and improve the reliability and validity of our data.
Our lab course for creativity with catheters help our students step into the world of molecular biology and synthetic genetics. This year, our project is on probiotic meditative serotonin production for depression treatment. Through this immersive, hands-on lab experiment, students gain insight into authentic scientific research practice, while developing skills and knowledges necessary for joining in advanced academic competitions such as BBO and IG.
Here at WUIS, inquiry forms the basis of much of our pedagogy and much of our education. And at WUIS, science no different. We don't learn science from textbooks, we don't learn science through exams. We learn science through experiential learning, laboratory work, experiments, asking those difficult questions and then looking for either the right answer from the experiment or the experiment leading you to the next stage of the question. Here at WUIS, we live science, we love science. It forms the basis of inquiry and what we do.